Hello all. So in this lecture, we will be discussing information theory. So basically, what is information theory? What is the need of it? And in this video, we will try to develop some intuition, or we can say some motivation to study this information theory, right? And this is a very important chapter in digital communication systems. So let's start. Basically, information theory is fundamental to understand and characterize the performance of any communication system, right? So whether it is analog or digital, information theory is needed. Okay, that is whether it is analog communication system or digital, information is needed. We will be seeing the analog source and digital source, okay, which is generating discrete information in later videos. But for time being, just focus that we are discussing digital communication system, right? So let's say this is the source, right? So this source will generate information, or we can say message signal. This message signal is being encoded by the encoder. Okay, so let me write what each block will do. So source produces message signals, while this encodes message signals to produce stream of bits, right? So basically the output of this will be some bits, okay, 0 1 1 anything, okay, just a random bits we are writing here. So typically what we want is that we need to convey this information to the destination end. This is the source end, and obviously by encoding and some other type of processing, okay, we need in any communication system to transfer the information, right? So we need to convey this information from source into destination end, okay, with the use of minimum number of source. Important point. Okay, what we want to use minimum resources, we can say, right? So, and obviously what are the resources over here? The resources are time or bandwidth. Okay, for example, time, or we can say bandwidth, right? So that it will be cost effective also. So we would like to encode or represent each message using fewest number of bits. Okay, so this source is producing message signals, right? So we need to encode this message signal, okay, so that it will form stream of bits. So by encoding this encoder, we need to design then the efficient encoder so that using minimum number of bits, we can encode the maximum information, right? So that we can use minimum number of resources. And information theory allows us to precisely do the same. Okay, and here comes the need and the major usefulness of information theory. So information theory enables us to do the same. And what is that? It is that to convey maximum possible information using minimum resources, right? Or you can say using fewest number of bits, right? So we will see the encoding techniques, okay, later on. There are two techniques, okay, so we will be seeing them, how we can encode, right? But for time being, just focus on the introductory part, right? So information theory represents maximum information using fewest number of bits. So in one line we can say represent maximum information using fewest number of bits. And in other words, we can write it like, we can say, to maximize information per bit, right? Obviously now since the bits are now reduced, okay, whatever message is being conveyed by more number of bits earlier using information theory, that message is conveyed using fewer bits, okay, as compared to previous one. So obviously we can say we have, what we can say, we maximize the information per bit. Obviously the per bit information will be maximized. So now one question may arise in your mind, that how to characterize something abstract, okay. Obviously this information is abstract value, okay. So how to characterize this? For example, let me give one simple example, okay. Let me try to give some example which is helpful in understanding things. Height, weight, all these are physical attributes, right? So all these physical attributes can be characterized easily. So are characterized easily, okay. We can characterize easily, but the question is how one can characterize something abstract, okay. Abstract means that we cannot touch, or we can say that doesn't have physical existence, right? So abstract such as information, okay. Information we cannot touch physically. So how we can characterize this? And the answer lies in the information theory, that this information theory provides a physical measure of information so that we can precisely mind the word. It helps, okay, but not only helps, it helps precisely to precisely characterize the information of source, okay, or you can say generated by the source. So information theory is one mathematical framework, okay, or we can say quantitative framework. Now just consider one simple example. Let's say we have one source and it is generating symbols like S0, S1 and so on up till, let's say it is generating m number of symbols, so from 0 to m minus 1. And let's say the probability distribution of the generation of this source is, probability of generating the symbol S0 is P0. Similarly for S1 is P1 and so on up till PS m minus 1 is Pm minus 1. So how to characterize information? Now as we discussed that information theory characterize something abstract, okay, like information. So how we characterize information? So as per the information theory, the information of any symbol, let's say Si, okay, is denoted by, let's say, I of Si, and it is given by log to the base 2 1 upon its probability, right? So this is the basic definition of information, and this is how we can characterize, or we can say this is the mathematical framework to characterize the information which is provided by information theory. So this is very important thing, right? And also directly we can write log to the base 2 1 upon pi, right, of any symbol Si. We can write like this, and obviously these are in its unit is bits, right? So here we can say information, that is I of Si, depends on probability of occurrence of symbol. Also, the dependency is like this. It is inversely proportional to the probability, right? This is the dependency. And what does it mean? It has very good example in real life, and you all are facing this thing in day-to-day life, but we are not noticing it. Okay, so over here I will tell what is this thing. Okay, this thing which I have written, this inversely proportionality, this relationship is very much important. Okay, and we will be discussing it in a minute. And obviously one can see here that information content has nothing to do how it is represented. Okay, how it is represented by a way or anything, it has nothing to do it. Rather, it depends on the probability of occurrence of the symbol. We can see from the information theory, and information theory totally depends on probability of occurrence of the symbols only. Okay, it has nothing to do how you represent it, right? So now let me explain that real life example. In this equation, let's say if pi is 1, if pi is tending to 1, then I of Si will be log to the base 2, 1 upon 1 is 1, and we know log 1 is 0. And if pi will tends to 0, it means that probability of occurrence of symbol, ith symbol, okay, that is Si, is 0. Then we can say I of Si is log infinity, and which is nothing but we will tends towards infinity, right? So we can see over here that symbols with low probability of occurrence over here, low probability of occurrence has more information associated with them, whereas the symbol with high probability of occurrence has less less information, okay, with them. Means that the events which are happening daily, okay, we will not notice them, okay, because if they are happening daily, then their probability will be 1, and so the information in them will be nothing, nearer to 0. But the symbols or the events that are happening very rarely, okay, we will notice them in a daily life. And obviously the news channels are doing the same thing. Whatever is happening, whatever is happening in daily life, and they will not show them on their TV channels, right? Because there is nothing information, there is nothing new in that. Whereas something rare will happen, they will definitely show, okay, by advertising lots and lots of hoardings and all sort of things, right? Because it has more information attached to it, right? So, and this information theory is providing us the mathematical framework which is compatible and which proves to be compatible with the real life also, as I said the example of news channel, right? And that's why we can say rare events has higher information, while frequent events have less information associated with them, right? So this is how information theory characterize the information, okay, and this is compatible, and this is giving us the feeling, that intuition, that yes, this is the correct way of expressing the information, because it is expressing correctly the day-to-day life events which is occurring, okay. So that's why information theory is needed. From next lecture we will be starting with entropy, and then further related terms like mutual entropy and mutual information and so on. So that's all. Thanks. Stay tuned.